General annuities. You are shopping for a $100,000 mortgage and the bank has quoted you a rate of J2 equals 6%. You will make monthly payments for 20 years. How much will your payments be? Again, this is very typical of Canadian mortgages. We usually have CY equals 2 and PY equals 12. That makes this a general annuity. Because we have a mortgage, we're taking a $100,000 loan. That's our balance at the very beginning. We want our balance to shrink. It's an amortization. And unlike a lease, it doesn't say what our end value is, how much we'll owe at the end. It should be zero. Unless you're told otherwise, assume that we pay off all of our loans completely. Our rate is J2 equals 6%, and it's a mortgage, so we're going to make the payment at the end of the month. Any money that we spend at the very beginning, that's part of a down payment. So this is an ordinary general amortization. We filled in most of this while I've been talking. And payment, well, that's what I'm trying to find. Finally, we just have N, and that's going to be 20 times 12. That's important. N always counts payments. Payments per year, not compounding period. So we're going to count how many payments we make over the lifetime of the mortgage, which in the end is going to be $240 payments. Let's run this through. We go into PY and we set that equal to 12. When I scroll down, you can see that CY has changed, so I have to set it to be different. When I scroll up, you'll see when you set CY, PY doesn't change. But when you set PY, CY changes. I always scroll around to make sure that everything has worked correctly. 100,000 present value, 0 is our future value. Compute that payment, and I get an answer of $712. And 19 cents. We're going to round out a little bit at the end. Let's talk a little bit more about general annuities. When we're using those formulas, what we do is we convert our interest rate to an equivalent one. So that we have PY equals CY. So what I would do here is I would say I've got J2 equals 6%. And I want to convert to J12 equals something. I'm going to do that. So we go to second, interest conversion. Our nominal rate is 6. CY is 2. I find that effective rate, 6.09. So let's write what the effective rate is. Then I take that effective rate, change CY again, and go back to the nominal rate. So this is what I would use in the calculation. No rounding, saving that entire thing. That's how it works in a spreadsheet like Excel, and that's how it works with the formula. We are lucky that we have a calculator that does that. It's doing that under the hood. And that's why we set it correctly, so that we can use our technology correctly. The important thing to always remember is that N counts payments, not compounding periods. So that's because things go together. So if, for example, let's say a 5-year mortgage, monthly payments, and J2 equals, let's go with 9%. N is going to be 12 times 5, 60 payments. And it's not going to be 2 times 5 equals 10 compounding periods. And that's because your calculator is actually changing that interest rate. I'm going to put a big X on this so that everybody knows that that's not there.